This class we discuss about arc welding. Arc welding is one of several fusion processes for joining metals. By applying intense heat, metal at the joint between two parts is melted and caused to intermix directly or more commonly with an intermediate molten filler metal. The principle of arc welding is electric arc is luminous discharge between two electrodes through ionized gas. The arc is formed between the actual work and the electrode. The electrode may be stick or wire that is manually or mechanically guided along the joint. Major components of arc welding are: number 1, power supply, AC or DC; number 2, welding electrode; number 3, workpiece; number 4, welding leads connecting the electrode and workpiece to the power supply. Arc welding machines are DC welding machines, motor generator set, transformer with rectifiers, AC welding machines. These are all the welding joints. That is, this is butt joint, this is single V, double V, single U, W. This is T joint, single bevel, double bevel, single J, double J. This is corner joint, this is lap joint, that is edge weld. This is arc welding setup. This is power supply, AC or DC. This is workpiece. This is an electrode. These two are welding cables. This is an arc. Now we will see the process. When electrode being near to the workpiece, an arc is developed which closes the electrical circuit. The arc temperature may reach 5500 degrees centigrade, which is enough for fusion of workpiece edges and joining them. Filling rod is used as an outside metal which melts and fills the weld pool. The outside metal may be consumable electrode which fills the weld pool. Filler metal and workpieces are similar chemical composition. Inert gases such as argon, helium are used to prevent contamination by oxide and nitride when the molten reacts with the surrounding atmosphere. Shielding is provided in the weld zone as a flux coating on the electrode. When a long joint is required, the arc is moved along the joint line. The front edge of the weld pool melts the welded surfaces when the rear edge of the weld pool solidifies, forming the joint. Solidification is the process of becoming hard or solid by cooling or drying or crystallization. The next is welding electrodes. In arc welding, an electrode is used to conduct current through a workpiece to fuse two pieces together. Depending upon the process, the electrode is either consumable in case of gas metal arc welding or shielded metal arc welding, or non-consumable such as in gas tungsten arc welding. There are two types of electrodes. One is electrode can be a rod or wire which is used to carry current. Number 2, it may be specially prepared rod or wire that carry current as well as melts and supplies filler metal to the joint. Most welding in the manufacture of steel products uses the second type. The next is types of electrodes. Number 1, bare electrode. Bare electrodes are made up of wire composition required for specific applications. Number 2, light coated electrode. Light coated electrodes have a definite composition. A light coating has been applied on the surface by dipping, brushing, spraying, tumbling and washing. The coatings improve the characteristics of the arc stream. The third is shielded arc or heavy coated electrode. These welding electrodes have definite composition on which a coating has been applied by dipping or extrusion. The electrodes are manufactured in three types: those with cellulose coatings, those with mineral coatings, and those whose coatings are combination of mineral and cellulose. Number 4 is tungsten electrodes. Non-consumable welding electrodes for gas tungsten arc welding are of three types. One is pure tungsten containing 1 to 2% thorium. Number 2, tungsten containing 0.3 to 5% zirconium. Number 3, pure tungsten. Number 5, DC arc welding electrodes. Direct current arc electrodes are designed either for reverse polarity, that is electrode positive, or for straight polarity, electrode negative, or both. Many, but not all, of the direct current electrodes can be used with the alternating current. Direct current is preferred for many types of covered, non-ferrous, bare and alloy steel electrodes. Sixth is AC arc welding electrodes. Alternating current is used in atomic hydrogen welding and in those carbon arc processes that require the use of two carbon electrodes. It permits a uniform rate of welding and electrode consumption. In carbon arc processes, where one carbon electrode is used, DC straight polarity is recommended because the electrode will be consumed at a lower rate. Number 7, non-consumable electrodes. There are two types of non-consumable electrodes. One is the carbon electrode is a non-filler metal electrode used in arc welding or cutting, consisting of a carbon graphite rod which may or may not be coated with copper or other coatings. Second is the tungsten electrode is defined as a non-filler metal electrode used in arc welding or cutting made principally of tungsten. Materials used for coating: number 1, titanium oxide, number 2, ferromanganese, number 3, silica floor, number 4, asbestos clay, number 5, calcium carbonate, number 6, cellulose with sodium silicate. Advantages of coated electrode. Number 1, due to increase in melting rate, the operation of welding becomes faster. Number 2, the coating compounds of potassium and sodium which supports arc stabilization. Number 3, it produces lag over the weld which reducing the changes in brittleness, smooth surface and protects from atmospheric contamination. Number 4, during welding, sputtering of metal is prevented. Factors to be considered for selection of electrode. Number 1, the type of metal to be welded. Number 2, the welding position. Number 3, the type of electric supply, AC or DC. Number 4, polarity of the welding machine. With this, I conclude my lecture. Thanks for listening.